Innovative and dynamic learning, getting students towards new normal. You are watching Telescuela of the Division of Agusan del Sur.
Math, TBI, Math, the lead.
Good morning, dear grade 8 learners. How are you today?
We are fine.
Great. Anyway, I have a question for you. Do you love to travel?
Yes, we do.
Me too. For sure, we have these common reasons. 1. It is fun. 2. It gives us first-hand experiences of the things we see on TV or read in books or in papers. But do you realize how much mathematics is involved in traveling? You'll find out in this first video of Math 8 Quarter 1 Module 5A about multiplication of rational algebraic expressions.
Math, TBI, Math, the lead.
I am Teacher Jen and we'll be together for the next 20 minutes. Ready? Your previous lessons on fractions taught you that greatest common factors or GCFs can be divided out either before or after the multiplication process. To recall, let me show you fractions in which their GCFs are divided out after multiplying them. Let us have fractions 5 over 10 times 2 over 6. To find the product of these fractions, we have to perform the following steps. Step number 1. Multiply the numerators and denominators. So, 5 times 2 equals 10 and 10 times 6 equals 60. 10 over 60 is our initial product. Step number 2. Find the GCF of the product of the numerators and denominators. To perform this particular step, let us first look for the prime factors of 10 and 60. The prime factors of 10 are 2 and 5, while for 60 are 2, 5, 2, and 3. Notice that both 10 and 60 have common factors 2 and 5. These factors 2 and 5 are called the GCF of 10 and 60. Step number 3. Divide out the GCF of the product of numerators and denominators. Simply put slant lines on the GCFs that are 2 and 5 because their quotient is 1. Step number 4. Simplify the remaining factors. Because 2 and 5 are already divided out, the remaining factor of 10 is just 1, while for 60 the remaining factors are 2 and 3. Multiply them, 6 comes out. Therefore, 1 over 6 is our final product. Now, let me show you how to divide out GCF before multiplying fractions. Let us take again the product of 5 over 10 and 2 over 6 by dividing out GCF before multiplying. Step number 1. Find the GCF of the numerators and denominators. This step is telling us to look for the prime factors of our individual numerators and individual denominators. Our individual numerators are 5 and 2, with prime factors also 5 and 2. Our individual denominators are 10 and 6, with prime factors 5, 2, and 3 and 2 respectively. Notice that the numerators group and the denominators group have common factors 5 and 2. These common factors are the GCFs. Step number 2. Divide out the GCF of the numerators group and the denominators group. Or simply, put slant lines over the GCFs, which means that we have divided these factors and their quotient is 1. Step number 3. Simplify the remaining factors. Because 2 and 5 are already divided out, The remaining factors for the numerators group is just 1, while the denominators group has the remaining factors 2 and 3, which when multiplied equal to 6. Therefore, 1/6 is the final product.
Now, your turn. Try to solve and show the solution of 3/9 times 12/15. If your answer is 4/15, then you are correct. Let me emphasize that when multiplying fractions, greatest common factors or GCFs can be divided out either before or after the multiplication process. I told you a while ago that there are so much mathematics involved in traveling. Consider this next example.
Coronavirus disease 2019 or COVID-19 affects everyone. Governments have employed various proactive measures to flatten the curve of its spread. All these measures head towards keeping everyone at home as much as possible. In effect, many have lost jobs and food on the table becomes scarce. Driven by the spirit of helpfulness, however, your church mates decided to distribute relief goods to different places. Using the church's vehicle, they travel at a speed of 30 km per hour. How far will your church mates reach after 15 minutes of travel? Remember that speed times time equals distance. We can arrange these terms into a table with 3 columns, each term as the heading. From the problem, 30 kilometers per hour is speed and should be placed in the column for speed, while 15 minutes is time and should be placed in the column for time. The missing in the problem is distance, and that is what I will solve for. To proceed, time should be in uniform unit, so I can either convert hour to minutes or minutes to hour. But for this time, I will convert 15 minutes to hours. So, 15 minutes equals 1/4 of an hour. I am now ready to multiply 30 kilometers over 1 hour times 1 hour over 4. I'll divide out GCF before multiplying. Step 1. Find the GCF of the numerators and denominators. This step is telling us again to look for the prime factors of our individual numerators and individual denominators. Our individual numerators are 30, kilometer, 1, and hour, and their respective prime factors are 5, 3, 2, kilometer, 1, and hour, while our individual denominators are 1, hour, and 4, and their respective prime factors are 2, 1, hour, and 2. Notice that the groups of numerators and denominators have common factors 1, hour, and 2. These factors are called the GCFs. Step number 2. Divide out the GCF of the numerators group and the denominators group, or simply put slant lines over them, which means we have divided them out and their quotient is 1. Step number 3. Simplify the remaining factors. Because the GCFs 1, hour, and 2 are already divided out, the remaining factors for the numerators group that are 5, 3, and kilometers have to be multiplied, and the result is 15 kilometers, while the remaining factors for our denominators group also need to be multiplied. However, there's only one term left for our denominators group, and that is 2. Therefore, 15 kilometers over 2, or 7.5 kilometers, is the final product, or the distance we have been looking for.
You see, indeed, there is so much mathematics in traveling. The methods that we used in multiplying fractions We are also the same methods to be applied when multiplying rational algebraic expressions, namely, Method 1. Divide out GCF after multiplying rational algebraic expressions. Method 2. Divide out GCF before multiplying rational algebraic expressions. Sit back and relax. I will show you the details of the methods mentioned. Observe as I will show you how to use Method 1 or divide out GCF after multiplying regional algebraic expressions involving monomials. I will be using 15y over 2y times 2y over 5x squared.
Math. TBI. Math. Dali.
Let us now multiply 15y over 2y times 2y over 5x squared using method 1 or divide out GCF after multiplying rational algebraic expressions. The given expressions are composed of monomials. To find their product, we'll proceed this way. Step 1. Multiply the numerators and denominators. So, 15y times 2y equals 30y squared. And 2y times 5x squared equals 10x squared y. Then, 30y squared over 10x squared y is our initial product. Step 2. Find the GCF of the product of the numerators and denominators. To perform this step, let us look for the prime factors of 30y squared and 10x squared y. The prime factors of 30y squared are 3, 5, 2, y and y, while the prime factors of 10x squared y are 5, 2, y, x and x. Notice that both 30y squared and 10x squared y have common factors 5, 2 and y. These common factors are the GCFs. Step 3. Divide out the GCF of the product of the numerators and denominators, or simply put slant lines over the GCFs to signal that these have been divided out and the quotient is 1. Step 4. Simplify the remaining factors. Because 5, 2 and y have been divided out, the remaining factors of 30y squared are now 3 and y, and the remaining factors of 10x squared y are x and x, which when multiplied equal to x squared.
This time around, I will use method 2 or divide out GCF before multiplying rational algebraic expressions. Still, I will be using 15y over 2y times 2y over 5x squared.
To multiply 15y over 2y times 2y over 5x squared using method 2 or divide out GCF before multiplying rational algebraic expressions, we'll proceed this way. Step 1. Find the GCF of the numerators and denominators. This step is once again telling us to look for the prime factors of our numerators and denominators. Our individual numerators are 15y and 2y, with the prime factors 3, 5, 2, y and y, while our individual denominators are 2y and 5x squared, with prime factors 5, 2, y, x and x. Notice that both our numerators group and denominators group have common factors 5, 2 and y. These common factors 5, 2 and y are called the GCFs. Step 2. Divide out the GCF of the numerators group and the denominators group, or simply put slant lines over the GCFs, which tells us that these GCFs have been divided out and their quotient is 1. And finally, step 3. Simplify the remaining factors. Because 5, 2 and y have been divided out, the remaining factors of the numerators group are just 3 and y, which when multiplied will result to 3y. And in the same manner, the remaining factors of our denominators group are just x and x, which when multiplied will result to x squared. Therefore, 3y over x squared is the final product.
The methods illustrated by the previous examples can also be used when rational algebraic expressions involved polynomials. I will use method 1 or divide out GCF after multiplying rational algebraic expressions. I will be using x squared minus 4 over 2 times 4 over x minus 2.
Let us find the product of x squared minus 4 all over 2 times 4 all over x minus 2 using method 1 or divide out GCF after multiplying rational algebraic expressions. The given rational algebraic expressions are involving polynomials. To find their product, we will proceed this way. Step 1. Multiply the numerators and the denominators. So, the numerators x squared minus 4 and 4 will be multiplied using distributive property. By performing the distributive property and simplification, the result is 4x squared minus 16. Then, the denominators 2 and x minus 2 will also be multiplied using distributive property. By using the distributive property and simplification, the result is 2x minus 4. Then, our initial product is 4x squared minus 16 all over 2x minus 4. Step 2. Find the GCF of the product of the numerators and denominators. To perform this step, let us look for the prime factors of 4x squared minus 16 and 2x minus 4. By factoring difference of two squares, the numerator 4x squared minus 16 has factors 2x minus 4 and 2x plus 4. Factoring further the greatest common monomial factor or GCMF, the final factors of 4x squared minus 16 are 2, x minus 2, 2, and x plus 2. On the other hand, by factoring GCMF also, the factors of the denominator 2x minus 4 are 2 and x minus 2. Notice that both 4x squared minus 16 and 2x minus 4 have common factors 2 and x minus 2. These factors are called the GCF. Step 3. Divide out the GCF of the product of the numerators and denominators. To perform this step, recall that the initial product is 4x squared minus 16 all over 2x minus 4. Using the factored form of the initial product, we have 2 times x minus 2 times 2 times x plus 2 all over 2 times x minus 2. Then, to simplify them, just put slant lines over the GCFs 2 and x minus 2 to indicate that these have been divided out and their quotient is 1. Step 4. Simplify the remaining factors. After dividing out the GCF 2 and x minus 2, the numerators has remaining factors 2 and x plus 2, and all the factors of the denominator are divided out. In effect, by using distributive property, the product in reduced form is just 2x plus 4.
This time, I will use method 2 or divide out GCF before multiplying rational algebraic expressions. I will use x minus 5 over x squared minus 7x plus 10 times x squared plus x minus 6 over 5.
Let us find the product of x minus 5 all over x squared minus 7x plus 10 times x squared plus x minus 6 all over 5 using method 2, or divide out GCF before multiplying rational algebraic expressions. Let us proceed this way. Find the GCF of the numerators and denominators. That's step 1. This step is telling us to look for the prime factors of our individual numerators and individual denominators. From the problem, our individual numerators are x minus 5 and x squared plus x minus 6. To look for their prime factors, retain x minus 5 and factor the trinomial x squared plus x minus 6. The factors of our numerators group are x minus 5, x plus 3, and x minus 2. On the other hand, our individual denominators are x squared minus 7x plus 10 and 5. To look for their prime factors, factor the trinomial x squared minus 7x plus 10 and retain 5. So, the factors of the denominators group are x minus 5, x minus 2, and 5. Notice that both the numerators group and the denominators group have common factors x minus 5 and x minus 2. These common factors are the GCF. Step 2. Divide out the GCF of the numerators and denominators. To perform this step, we need to express the given expressions into the factored form. Therefore, x minus 5 all over x squared minus 7x plus 10 times x squared plus x minus 6 all over 5 will become x minus 5 all over x minus 5 x minus 2 times x plus 3 times x minus 2 all over 5. Next, put slant lines over the GCF x minus 5 and x minus 2 to indicate that these have been divided out and their quotient is 1. Step 3. Simplify the remaining factors. After dividing out the GCF x minus 5 and x minus 2, x plus 3 remained in the numerators group and 5 remained in the denominators group. Therefore, x plus 3 all over 5 is the final product.
Which method do you like to use when multiplying rational algebraic expressions? Method 1 or method 2? Regardless what method you prefer, always remember that the correct answer matters most.
Math. TBI. Math. The lead.
Yay! Everyone deserves high five for having reached this far. High five, high five, high five. At this time, you will apply your learnings about multiplying rational algebraic expressions. Answer the What's More section on page 9 of Math 8 Quarter 1 Module 5A. Our episode of multiplying rational algebraic expressions ends here. Do not miss to watch the next video on dividing rational algebraic expressions. That is still a part of Math 8 Quarter 1 Module 5A. May you continue to enjoy learning mathematics. Keep safe, everyone. God bless us all. Bye-bye.